This is a video from the Exam 1 review, and we're going to take a look at problem number 11. Suppose U is the vector 2, 1, 1, 2. A is the vector 4, negative 4, 2, negative 2. The dot product of U and A is equal to 2 times 4 plus 1 times negative 4 plus 1 times 2 plus 2 times negative 2. But this is equal to 8 minus 4 plus 2 minus 4. But that's 2. If I look at the norm of A, this is equal to the square root of 16, right, that's 4 squared, plus 16, well, that's negative 4 quantity squared, plus 4, 2 squared, plus 4, negative 2 quantity squared. That's the square root of 40. Now we're ready to look at part A. So we want to find the vector projection of U onto A. Well, I'm going to take the scalar U dot A divided by the norm of A squared, and I'm going to multiply that scalar by vector A. So we did the hard work over on the other side. So that's 2 over the square root of 40 squared times the vector 4, negative 4, 2, negative 2. So the answer to part A is 1/5, negative 1/5, 1/10, negative 1/10 when we're all done. Part B. Suppose I want the vector U minus the vector projection of U onto A. Well, hard work's done, right? So U is the vector 2, 1, 1, 2. The projection of U onto A is the vector 1/5, negative 1/5, 1/10, negative 1/10. And when we do that calculation, we come up with 9/5, 6/5, 9/10, 21/10. Now, one final thing I want to point out. So if we look over here, we did the projection of U onto A. What about the vector projection of A onto U? Okay, now let's remind ourselves. U is the vector 2, 1, 1, 2. And A is the vector 4, negative 4, 2, negative 2, okay? The norm of U is the square root of 4 plus 1 plus 1 plus 4. That's the square root of 10, okay? Now, remember, I'm going to take the scalar A dotted with U divided by the norm of U squared. So I'm going to take that scalar times the vector 2, 1, 1, 2. So this is 2 over 10 times the vector 2, 1, 1, 2. So coming down here, the projection of A onto U is, so if I go through this, I'm going to get 4/10, which is reduced to 2/5, 1/5, 1/5, 2/5. And the most important thing I want you to notice is that in general, the projection of A onto U, and this is a vector projection, this is not equal to the projection of U onto A. So again, the vector projection of A onto U is not the same as the vector projection of U onto A. And that'll conclude this video for the Exam 1 review. This was problem 11. Thank you.